Righto, we're back. It's a little bit later. I've fed my chickens and I fed my pigs, and the guys in the US have been doing their thing. And I'm going to open this one up. And supposedly they fixed the TPS problem. We turned the map sensor on in the last video from the first video, and I sent them a little video of the TPS, but I think they had that pretty much sorted. And they've gone for 3 drives, which has given me some logs. And they've got them sorted, and they've done that, and they've called it a night. They've said, we've had enough, we're tired, we're going to get some sleep. So while they're sleeping, I'm going to do some work. Pretty normal, actually, when I'm working on race cars and working on logging. Normally, guys go to sleep, but I keep checking through and checking log files. Right, so I need to bring up a log file, an open log file, and there should be some new ones in there. If I go to my downloads, and look, 6:47 p.m., 6:47 p.m. 3-minute idling, 2nd and 4th gear pull, and a slow cruise to 80 mile an hour. It's very quick. So let's have a look at this one first. We'll look at some idles. And the other thing I can do, which is really interesting, guys, if you're doing this sort of work and you want to look at your changes that you're making, is to do a file compare. And if I go to the downloads, I should actually be able to find this one, that one there. And I'll double click on it. And there's the difference. So the problem being, of course, that they were trying to make it idle down here because there wasn't a map sensor. Now they've actually got numbers that are a little bit more normal, possibly a little bit big in here. So they they'd pulled a lot of fuel out because it didn't have that map sensor. Possibly a little bit rich in here now in the idle area. Not quite what I'd expect, but probably not too far off. Let's get in, let's have a look through it, see what it's got. They talked about a bank-to-bank difference, but of course it could have been failed plugs because it was running without a map sensor. And we probably should double check the old TPS setting and check that they've done that correctly. I'm just going to close that file, compare. We're back to there. And I've got some logging happening in there. Now I'm going to go through quite steadily and check for any issues throughout the whole thing, throughout that whole tune. This one here, I've got speed, and they've just had it idling, and I've got the trigger signals, yes, for both trig 1 and trig 2. It allows me to show that that is doing what it should. Hopefully they've checked their base timing, and I haven't actually had a chance to talk tonight. I was cooking dinner while they were eager for me to get into this, but I had other things to do. Of course, I've got to feed myself because you've got to keep yourself in good order. This is some lambda. So that's your mixtures. And I want to look at the idle speed control as well while we're going to be in here. Now, as you can see here, it's quite a wiggly line. But you also want to look at the scale over here. So that scale's quite close together. So we've got a 23.5 kPa to the top of that scale is 26. Something weird happened here, isn't it? And the TPS, if it is idling, I actually want that TPS to sit at 0 all the time. But in saying that, if I put that on a normal scale and I went properties and I went TPS, it's 0.4, 0.5. So there's probably a little bit of leakage somewhere in the system, just a little bit of voltage leakage. But if I double click on here, it allows me to just do minimum maximum. So if I put it on a minimum maximum, so changing that scale on the side, it's pretty much, I would expect it to be a flat line. And again, that's to do with the scaling. If you want to get in really close and you look at it like it was, then you will see those little anomalies. But it's 0.1%. Not the biggest deal, but might be worth just looking at that, checking connections. Or what you can do is when you calibrate it and you drop it back to 0, just rest your foot a little bit to give it 0.05 and push yes when it's being closed, or okay is when it's being closed, and it just takes out that little bit of flutter at the bottom. Righto. I can push okay. So something happened here where it jumped around a little bit, did something a little funny. Air fuel ratio is here, and hey, they're not actually too far off. Sitting at idle, they so the targeting point is 14, and we've got 13.5 and 13.77. That's pretty close. We can probably lean that off just a little bit to head to that 14. Once it's up and sorted and running, anywhere between about 14 to 14.7, 14.8 is fine for idle. And this is a standard engine. So that can be leaned off. And of course, if we go here and we go, that's where it's sitting, and we go to in the tuning file, that's where it's sitting in that tuning map. Okay. It's actually looking like, if I looked at these numbers, I would suggest that the injector setting was too big. So we've had to, it's suggesting it's got smaller injectors than is actually showing, and that's why these numbers are a little bit bigger than I thought I'd like. Maybe there's an air leak there. They're not too far off, but it is a little bit. They're a little bit bigger than I would normally expect. So I just grabbed one of my tuned maps, and you can actually see there the numbers aren't quite as big. And it's just from experience and doing lots of these. You look at them and you go, it doesn't look too bad, but it's a little bit different to, as I said, what I would expect. Doesn't mean it's wrong, just it's different to what I'd expect. All right. Hold there for a minute. I'm just going to go do some looking of some other stuff, and if I see anything of interest, I'll come back to you. When I do this, I often have to familiarize myself with each map, and the G4X is really good at doing that far faster than the earlier ones. I quickly whipped in, and of course we've got down here, we've got the active fuel table. I loaded a second one when I sent this map over. When I put it together, I put together a known map that is something close to what I would normally start with in these tunes, and it gives the guys a bit of a head start. There is a air temp correction table, so that's under the fuel menu. It comes down, fuel corrections, inlet air temp correction, and you'll see here that you really want to aim to keep your air temps between sort of 10 and 30 degrees. At the 30 degrees there is fuel starting to come out, and this is a specific fuel model that is commonly used, and it commonly works for most engines with an efficient air intake system. These numbers work well for an air temp correction. It will alter depending where you put your air temp sensor though. There is a fuel 4D table. There's a dual fuel table which is solely on I think it's an auxiliary, a virtual auxiliary on off. We got acceleration, fuel, overrun fuel cut, and I've normally got it on. Oh, yep, that is on. So I will see a drop in mixtures when it's decelerating. So I will see a leaning of the lambda. Closed loop lambda is normally off, so I normally leave them off, so it's not trying to do a whole lot of corrections while you're trying to tune it. So that's important as well. So when you're actually tuning the engine, you generally start with the closed loop lambda off, so you're not fighting that. You make your adjustments. Sometimes at the end of it, you can tune on. You put the closed loop lambda on and use the corrections to make your adjustment. So say it's pulling out 2% of fuel pretty much everywhere, then you drop the main map by a 2% fuel, or you make a 2% fuel reduction. Shouldn't be any individual cylinder trims. We've got an AFR target table. Now, if you're looking at this, you'll see it is quite rich at the top end. Just 6. Oh, we've got 5 to 8 grand at full noise, 12 to 1, and then that is quite rich. Sometimes I will adjust that, but the great thing on modeled tuning is what the computer thinks, or the way the computer works, is it believes that this table, okay, matches that table, and I'm on the wrong one. Doesn't matter, because this is probably the map that I sent him, so I'm going to have to flick back to their one, but it assumes that this table here, okay, is matching that table there. So if you change these numbers, the mixture will change when it's on modeled, okay? Even without the lambda sensors working, it'll change it, and it may be correct. Right, I better go back to their one. I'm still not on their one. Yep, that's their one. The reason I'm confident that we were close is my other tune that I used is one of my generic tunes that I use. Okay, so I know it's pretty close. Through the ignition, same deal, and now we've got coil on plug. Now what happened, they were telling me that when they were setting it up, they were running it, they blew the coil fuse, a 20 amp coil fuse. And I do say fuses are for pussies, but there is a reason to keep them. Now that would have blown because of this. They're running R8 coils, and as the battery voltage dropped down, so did the dwell time. And as the battery dropped off more, the dwell time climbed, so it would have pumped up the amperage on that coil fuse, and that, I believe, is why it would have blown. So this is designed if your battery voltage drops. You've got to be a little bit careful, because there can be a spike on startup if your battery is getting weak or it drops off. But it's designed so as the battery voltage drops, the spark output increases. So the engine is hopefully safer. Okay, and that's the idea behind that. Okay. Again, there are 2 ignition tables. I've got quite a conservative table in there. That'll work just fine for what they're doing. And then I do have one if you're running a really good exhaust, really nice flowing headers and extractor type headers with good scavenging, it's going to affect timing, different intakes, those sorts of things. Then I'm going to adjust or use this timing table. But in most cases, the first timing table is the most suitable one. Okay. This is the RPM table, or the rev limit table. You see when it's colder, it's a little bit lower. As it warms up, it increases up to a running temp 6,800. And then if it gets too hot, it does have a cut at 120. So you've got to watch that if you are drifting in hot climates. If it's a short run and you are getting hot, you may experience an ignition cut or a limit, and a rev limit comes in. So that has to be exercised and used with discretion. For example, if I was doing a jet boat, I would not put that cut on there. I'd put a light on the dash and no cuts, because if it's getting hot and you're in the middle of a rapid and you get a rev cut, the boat stalls out or the boat loses power and you go backwards down the river. It could be very, very dangerous. Burnout cars, don't put cuts on them. If the guy's got a light on the dash and he chooses not to back out of it, it's his choice. So there are some reasons for not having cuts in there, but it's on a case-by-case basis. Okay. Now, we got a fan and a fuel pump and a purge. I'm wondering about idle speed control. You see, this is why I was looking at that idle speed. I'm not certain they've got an idle speed control unit fitted to the engine, that'd be a little bit disappointing, because it's nice to have proper idle speed control for warm up and even for warm running. It would be really nice to have that in there. I'll check with them tomorrow. I better make notes of it. Right, I was just looking through it. The faults for the ethanol sensor, to give some guidance for Eric and Eric to solve it while they're over there, and I'll probably be sleeping while they're trying to fix this problem. So they've got it wired to DI1. It's a frequency, which is normal. There is a chance that the problem is not there, is that it needs the pull-up resistor turned on, because there are some differences in the sensors. Under the runtime values, the live data, I sometimes call it, it does have some bits and pieces of what's happening with the ethanol sensor. So I highly recommend getting in there and having a look at that at the same time when the vehicle's running, and trying to solve why that ethanol sensor is faulting. At the moment it's only got petrol on it, and there's no second tune in there anyway, so we're okay. Right, moving forward. And as I said, very easy to have a look at what's going in, because we've got this here. We can check out the input pins, and a TPS and 2 lambdas. Now with this one, you'll see here it's got error value low, error value high. At 0 volts and 5 volts, it's effectively turned off for the fault codes. And you often do that with oxygen sensors with the wideband units, because when they're warming up, they fault. So you end up getting all these fault codes. So that is why that is like that. That is very normal. With dual lambda, we probably need to look at setting up some banks for the engine as well, to know which side they are on. For a few we do closed loop, I'll be looking at them evenly. I'll be looking at them and seeing if there's a difference between bank to bank, and then making a guidance of based on lambda 1 and lambda 2. I normally put lambda 1 to the same side as cylinder number 1, or bank 1, and then lambda 2 would be on the cylinder relating to the second bank, or cylinder 2 in this case, which is of course the right bank. Left bank is where number 1 is. Now I've got to check with them that they have gone and they have calibrated. So I'd like to see them put a timing light on it and confirm that the base timing is set. I was making notes for tomorrow, so to do base timing, you click on this one, it says set base timing, brings up that screen. You put your timing light on it and it will be locked to the ignition timing 2. It'll be locked at that number, and if it isn't, you adjust this number until it is. Then you rev it and it should stay steady. If it does move, then you adjust that one. Those numbers are probably pretty close. They could be 4 or 5 degrees out though. Sometimes we're 355, but they changed it on the X. So just check that, please. Timing light on it on number 1. So whip the coil out, put a lead in it, check that base timing. For idle speed control, they've got this figure here, this one here that says idle ignition control. So we can use the ignition timing to control the idle to some degree. And so if we don't have a solenoid attached, then we might look at that. And then you use the target table, that one, and the base idle table to give us the desired idle. Now hopefully if they've set a base idle anyway, even if they're not running an idle speed. So I've warmed it up and I've adjusted the idle stopper, which is not the one on the top of the throttle body, it's the one underneath the throttle body. Okay, tucked, it's a bit of a pain to get to, but it's the bottom one. And when they adjust that, you then have to recalibrate the TPS. Here is one of my screens that I check over. I'm sitting forward. So I look at battery voltage, coolant temp, air temp. Started high and it cooled off. That the map or the manifold gauge, either or. I still got that funny weird thing there. And oil pressure and fuel pressure. Now there is no oil pressure sensor allocated, but it's still showing 100 kPa of oil pressure. You might go, why is it doing that? Well, if we go back over here, configuration menu, and I look at the oil pressure under the analog volt menu, the error value is 100 kPa. So even though there isn't one there, it's showing 100 kPa. Okay, and that's why we see that in the log, even though there isn't an oil pressure input at this present time. I've got it on my notes to ask if there's one or why I didn't, because there is A in volt 4, and it'd be a good idea to put oil pressure into it. Right, I've got this screen, and this is the dwell or my timing settings that I check. And you look at the dwell time and it looks crazy, like it's going over a big range. But again, we've got to look at the scale on the side. So it's sitting, you know, there is 3, there's at 3, there's at 3, there's at 3. Let's see if I can just. And it's probably because it's rounded, this number's probably rounded to 1 decimal place, is why it's not seeing it. It's not even moving off that. So it looks crazy, but it's actually sitting at 3. Okay. And the ignition angle, I'm using my arrow keys, up and down arrow, to bring this in and out. And I don't have a navigator on the bottom to see where it is in the setup. And I probably should have that, one of those in there. You see it, that when it did that blip, it went up to 18, it went 1 degree. And this map change here, I'm still not quite sure what went on there. And then we're also going to look at the lambda, the mixtures. So we've got, here's our target. Here's lambda 1, here's lambda 2. And we see we've got about it's about 0.43 difference side to side. And it's very consistently different. And now it might be worth, could be tappets, could be an air leak, could be a slight different in exhaust or a little tiny bit of a leak in the exhaust heater. Any of those things are something that could be considered. Or it might just be normal. Some engines just flow a little bit different, and it's nothing to be really worried about. And chances are, we could put a correction across 4 cylinders, and that might be enough. But before we do that, we want to know that there isn't another mechanical problem that is causing a lambda difference. So right now, looking at this, I'm not going to change the idle settings. I'm happy with where they are, and overall what they're actually doing. So I'm going to leave that. I'm going to grab another log file, and we are going to see if we can do something else with the next one. And again, it's in my downloads. I just had to change properties, as you can see, very quickly change it so I could see the whole run. So they're accelerating, they're coming along, they're accelerating up, they've dropped off the throttle, accelerated again, dropped off the throttle. Green line is our target, and the blue and the yellow are the actual lambdas. So we can see here it is a little bit rich, considerably rich. It's rich, so pretty much it's quite rich through there. What's happening here? What have we got? So when we're looking at this, what we're looking at is in an ideal situation for tuning, would be on a dyno in a steady state, so we can bring it up to a certain revs and hold it there at a certain amount of load and let the mixture settle properly, and then we adjust it. Now with road tuning, it's not quite that easy because it's harder to do and hold steady state for a long period. So we've got here, we can see that they've been at that state, at that revs for a little while. There hasn't been a big change in the TPS, and it's still rich. So we're going to find that spot on the tuning map, and we're going to make an adjustment. And part of my going through this and doing a video for the guys is it allows them to tune things themselves. Hopefully get to a point where they can make some adjustments and feel confident adjusting their tune themselves. So from here to here, we are saying it is a little bit rich. I'm going to actually, we might just do this push play again, and it's not giving me the lambda reading. Just wait. What we're going to do is we're going to go stop, and I'm going to set up some extra numbers over here with those lambda readings, or I might set up another screen with the fuel map and those lambda readings. Just give me a moment. Here we go. I just tacked it on top of the other one. We're going to push. Oh, we're going to move it actually. We're going to move it back here. Let's move it back here, and then we're going to push play. And we could probably put a digital one, but we can see it is quite rich through there. It's rich through there. We're watching that. We're watching here and here at the same time, and it's quite rich through there, and very rich through there, very rich, and it drops off. So he dropped the revs there for a moment. It was just in here where it dropped the revs. Okay. Oh, we're going to play it again. So overall, it is a little bit richer than we would like. So we could really pay to tune that and pull some fueling out of it. I think I'm probably going to cheat and go grab one of my maps. Or I find another map that might be a little bit more suitable. So I've imported a map from one of my other tunes. Yeah, it's cheating, but it's a whole lot faster to get something a bit closer. And at the moment, I'm still trying to just broadly map out something that head us towards what we would call a base map, a good starting point to fine tune it. So what I've done is I've just compared it to itself. So I've just made some changes and to see, and then well I've made the change. I've imported the other map and then I've overlaid the map that I've just changed it from to have a comparison, so I can have a bit of a look. And then what I'm going to do is I'm actually going to run it through again. So I'm going to push the old sendy button there in a moment. Though I think what we might do is set up another screen and I'll show you some of the setting up. Okay, so we go up to here, we right click and we go new page, and we're going to call this fuel table adjustment. Okay, I want a navigator in here, so I'm going to go logging, navigator, add group. Nope. Oh, no, I actually I was meant to just add a parameter, but we should be okay. I normally go engine speed. Okay. And we spread it out and pop it down the bottom. Then what I want on this one is I want a couple of digital gauges. Might get away with a logged list actually. So if I wanted to run live data, I could have a digital gauge, but because it's logging, they're not going to let me do that. So I'm going to do, I think I might just do a logged values list. Probably do the job. Add parameter, fuel. Name to target. Lambda 1 and 2. I'm in the wrong place, don't mind me. So we'll put that in here. I'll set that up, come back to you, Mo. Okay, so I've got my log parameters list here. I've got a time plot of the mixtures there, the lambda there, and I've got my navigator at the bottom. And in this case, I'm just going to push play and have a bit of a watch. So everywhere down in here, this zone in here, it was getting too rich. And down there it's extremely rich. So we've already pulled fuel out just by changing my numbers already. So I think that's going to make a big difference by running these numbers. That's a decel, so that's not really an issue. It's a pretty steady, and it needed. Okay. So we've got the bottom numbers are what it was, and the black numbers are what it now is. That was a good run right there. So I've pulled quite a lot of fuel out of there, but not too much that I think it's going to go too lean. Okay, and so that's really important that we always work from rich to lean as well. Right, I'm pretty happy with those numbers that we've just slammed in. And over there, I might just change that very top line, which is normally in a decel zone. Now the boys have got one more run where they gave it a steady climb, and we're going to load that log as well and lay this into here and see what it's like, see what we think of it. I'm just going to look at that area again. Right, I'm just going to look at this end zone, and then we'll lay that other map on, the other log in, and we're going to have another look at that. But we're actually looking pretty good on. I think this change is going to make quite a difference to the way the car drives and performs, and it's going to be a bit nicer. Righto. I was just looking at this zone here, this area here. If we look at the lambda, the difference in lambda, and you can't see it, I'm pointing to the screen. It's a dumb thing to do over here. How about that? We got a massive difference between left and right. Massive difference. And I was just clicking through with my mouse. So I'm using my arrow keys left to right, and there we've got like 1.5 points of a lambda, 1.5 lambda difference. And then it evens out again. So that's something that I'm not so happy with. Come on, give me one more. There we go. Right, it was over here. So we've also got on the rich side, there's also quite a difference. and then going through this zone here. That's in a high vacuum area. So I think we could have an air leak on one side. Injector seals, have they been changed? I'm making notes. So when the engine comes into a high vacuum, like in a decel, see we've come off this TPS here in a decel zone, and we've come in through here, massive difference on the one side, which indicates to me that there's an air leak on vacuum. Okay. I'm happy with the changes we've made so far there. I am going to open another log file, and we are going to whip up here. So again, we've got another set of numbers to look at and compare. Now I'm expecting the numbers that I've just pulled up here to be rich, but of course I've already adjusted it, so you're going to go adjusting a second time. The rest of it's looking really good. I'm going to sit here and I'm going to tap my way through it. I'll play it a couple of times, just whip through to give me an idea. I will then often go through and I just go through each zone. And the idea at the moment is to give us a rough map out of the mixture to get it, or the fuel map, and the timing map, and the rest of the setup to get it kind of close. And then we're going to fine tune it. There's no point worrying about little tiny incremental differences and changes until we've got something that is reasonable and drives reasonable and gives approximately the right mixtures. At that point we fine tune and we go through in a slower way. Again, I'm just going to tip in and do this on my own at the moment, so I'm not having to talk. But I'm then at the end of this I will save each of these. I'll save the map, and I'm going to put it in the email and send it back to the guys in America. They know what to do. They're going to fire it into that car. They're going to start it. If they want to adjust the idle, they can watch the screen. And I haven't gone through that quite as much as I should have. So I'll probably look at that for them and show them how to adjust a little bit more there. And then they can hopefully give it a drive down the road, and they're going to watch the mixtures. If we look at things like acceleration enrichment, that will be playing a part in this, but that can be introduced more as we get it leaner, and it will develop flat spots from not having the acceleration enrichment correct, and that'll need tweaking. If you look in here straight away, we go with this. So 11 and 14 is the targets at 11. I've made quite a big drop there in the mapping, so I hope it doesn't go too lean. But it's also in a low load situation, so we can go far leaner than what it was at 11.5, because that is stupid. We could put turbo on it. I'm going to look at what's going on. Oh, wrong button. Here. So we've got a big a big difference in mixtures there. It is just after a decel, and it's been turned off for a long time. So there I'll go in and look if it's injector decel or the injectors are turned off. I can check inject duty cycles, and I generally set up multiple screens for doing that to see if there is a reason why it's got these big lean bits. After a decel, you can see there was a decel here and it didn't change quite as much. There's a big decel, a little one and a little one. They're both lean in there. They've both gone lean, so it would probably be from injector cut on the decel when he's come off from a big TPS drop. But generally, we've already made the changes that I think we should make. Again, massively rich. A few other things, of course, is in this when you've gone very, very rich, giving them a drive and checking the spark plugs are in good order. I'd normally say check leads and stuff, but it's got call and plug. So that's already been upgraded and sorted. I haven't seen any trigger errors, so I'm happy about that. As I said, I would like that timing, that base timing checked. Generally, I think we're moving on the right track. And I'm going to fire this map back, as I said, and the guys can see what it's like in the morning. Hope that's been helpful. Talk again soon. Catch you later.